All right, class, let's settle down. All right, this is Entities 201, so I hope you're in the right class. If you're not, go down the hall. I think there's Entities 101 maybe down there. All right, this is Entities 201 at Apollo GraphQL University. All right, we're all at the right place here, right? Just, it's not a real university yet, but let's roll with it. All right, Entities 201 at AGU. So welcome back, class of 2027 of AGU. Hope we all had a great break. You all took Entities 101 last semester, so I know you know all the stuff we learned there. We're going to go into 201 this semester. But first, a little bit about me, your course TA for the afternoon. All right, I am Shane Myrick. I am based in Seattle, Washington. My fun fact is I'm actually a part owner of an NFL team, so ask me that about the happy hour tonight if you want to learn more. Anyway, I've been at AGU for about 3 years now as a solutions architect. I previously was a software engineer at Expedia, where I built our GraphQL platform. And through my experience at Apollo, I've learned a lot about deploying router federation with many of our critical customers. So everything you're going to hear today is firsthand mistakes that I've coached and learned myself by trying to help customers do these things. So, all right, let's talk about our curriculum for the course today. We're going to first start off going in depth on entity resolvers. What does an entity resolver actually mean? How does it execute a query plan? Then we're going to talk about something that I call overloading entities. We'll kind of dive more into that. And then hopefully with that knowledge we're going to learn about a better way we can share data across our subgraphs. And then I want to wrap it up with a little bit of the sneak peek of the future of entities and what it means with the new GraphQL Federation spec. All right. So first, I know we all took Entities 101, but just as a quick review, hopefully everyone remembered our curriculum last semester. GraphQL is our type language, right? It's the way that we describe our APIs, but federation is the way that we describe the relationships of our graph and our entities, right? And types can be defined in many different ways in federation, right? So within the transactions subgraph here, right, I can say I know about a transaction, and I know that a transaction lives on a user, right? In your database, you might say, I have a reference to user ID, but in GraphQL and Federation, we actually say, no, I know about the type user, and I know there's a transaction on that user, right? So there's a way of describing the relationships that we have across our entities. All right, but first, so we all know that. We're all good, right? Yeah, okay. So, pop quiz. Is everyone ready? All right, you'll be graded on this after. All right. So, Entities 101 review. Where can we put the key directive on this here? Is it classes and objects, types and interfaces, or unions and scalars? You're right. It's types and interfaces. Classes and objects is not GraphQL, so hopefully I didn't catch you with that one. All right, next one. What does adding the @key directive do? Adds cache, implements a resolver, or marks the type as an entity? Yes. All right. We're all good. We know what we're doing here. All right. And then, can entities define fields across subgraphs? Yes or no? Yes. Yeah, we're good. 100% so far. All right, last one. All right. What does the @external directive do? This one's a little more advanced. Does it reference a field in data from another subgraph, hide the field from clients, or require a resolver to be implemented in the subgraph? Reference. Yes, great. All right, so we're all good. Entities 101. All right, let's move on because we're going to move past that stuff. All right, let's talk in depth on what's happening with our entities and our federated queries. All right, so let's say we have this simple query, right? We can query for a user, we get their transactions, and every transaction we can get an amount, right? Super simple. But we can go inspect this and say, well, what's happening under the hood? When we do that, we look at the query plan. Query plan tells us, oh, I'm going to go fetch users, then I'm going to hit the transaction subgraph, and then I'll go merge all data back together, right? But how? How does it just fetch transactions, right? What's happening? How does it just go get transactions, right? We didn't expose anything to just get transactions, did we? Well, that's where if you go inspect the query plan, there's a mode, by the way, in Apollo Explorer, where you can see the plain text view of a query plan. When you do that, you get this expanded view. And so you'll see here, we see our fetches, our flattens, et cetera. That first fetch, we fetch the users, and that is actually a real query that we can execute on the user's subgraph. We can call users and get their ID, right? So that's a real top-level field that exists. But the ones below, right, this fetch to the transaction subgraphs, that's not GraphQL, that's not a query I can execute. So what's happening here is the router is specifying what fields it needs, right? And it's picking out those fields that might not be specified from that query from before, and it's saying, hey, I need to go first get all the IDs, so then I can go select all the transactions based on that user. But if this is not the query to run, like, how can we just go and fetch from some random entity on a subgraph, right? Like, is there a query to say, on user, give me the stuff? Well, no. Actually, there's a secret query._entities field that exists in Federation. And this is what powers a lot of the stuff that actually happens underneath the query plan. If you want to learn more about this super secret special field, it's in the GraphQL spec, in the Federation spec on the Apollo docs, so you can go learn more there. But the short version is that this is a special field that exists that the router knows and is required to exist for subgraphs, and it's hidden from you from the subgraph libraries, right? So if you're using the Apollo JavaScript Apollo server, this is in the @Apollo/subgraph library, right? This is when you go and implement the __resolve reference function. This is how the router can then query that and say, the library is actually saying, when you call _entities, I'm going to map that back to a specific field. So what the router does, it says, I want to select some entities, and I want to specifically select the user entity, and I'm going to tell you I want these transactions and the amount, right? And what this also allows us to do is we can say, well, I could select multiple entities, not just users. I could do other things, other transactions, other types. And then for each one there, I can also say for each type of entity, I can pass in all the IDs required, right? So that's how I can get data from one subgraph to another, is adding it through the key. The key is the way in which we can share data across these subgraphs and add it to our query plans to start sharing data and get the subgraphs to resolve that data for us. All right, so you might think that's super cool, right? The key directive is actually doing some really powerful stuff under the hood. It's joining, it's doing query plans, right? So if you didn't know, Federation actually supports multiple keys, right? You don't need a single field. You can do both multiple keys and multiple field selections inside a single key. So let's say we have this other schema here. We have this user, and we have this currency code, right? Maybe this is like the user's preference of their currency code. And we know that in the transactions, there's a resolver that actually asks for the amount in the user's currency, right? And it actually takes an argument for the code. So how could we get that data from the user's subgraph, which lives over in the users, to the transaction subgraph? Well, could we add it to the key, right? Like we're doing above here? If we do that, then this is what we call overloading entities. This would allow us to always send that key to that subgraph, and we could use it to maybe then resolve that field, because it'd be in the __resolve reference function. So should we overload entities? The answer is no. You should not do this. You should not overload your entity keys, because what you're now sending is this extra info. If you did that, this would be the query plan that would execute. You're now sending this info every time to the transaction subgraph, but now you have to go to all the other places that you maybe define this key or this user transaction, right? And I have to go update their references, and I have to make sure they understand that they need to use the currency code. And then you could do that once, you could do that multiple times, but then also if I add this currency code, that starts busting our cache, right? Like I'm now adding more data to the cache that doesn't work with entity caching. What happens if the user updates their user code? Does that bust my cache for me? That doesn't work really well, right? So there's just a whole bunch of reasons why you should avoid overloading your keys. And I know it sounds helpful or pretty straightforward when I explain it this way, but we've had a limitation in the Federation so far that this is really the only way that you could maybe share data across different entities and types. So people I've really seen this used and abused in production. But there is another way that we can share data across our types, and it's called the requires directive. This has been in Federation for a while, right? I think, so this could be a way to maybe get that data there if we wanted, right? So Federation supports passing data from one subgraph to another, but requires that we link dependencies together on the same entity, right? So if we have the schema here, right, when we add requires to this amount in user currency, like what are we requiring? Because we only have the scope of the transaction type. We have no reference to the user, like how do we get the data that we need here? It doesn't work, right? So we can't use requires. That means we have to put it up in the user type and say, okay, well, I know that when I resolve a transaction, like I might have someone might ask for the amount in user currency field, so like I will, I guess, require it every single time and always pass it down. But that still doesn't like pass it down. I still have to get that data when I resolve it in the subgraph and like pass it to the resolver of the other one, the amount in currency. So like this, you could do this, but there's still more code you have to write, and it just gets more and more complicated, right? And so, and also on top of that, like it doesn't remove the argument from the schema. Like people might still pass in their argument. It exists in the query. Clients could query for it. So what we really want is some way for the router to select data and actually pass it into our different arguments, right? And that hasn't existed until today. So that's what I'm here to talk about, is a better way that we can share our data. What we actually want to have happen here, kind of expanding out, I drew a line to draw both subgraphs. What we want to have happen is we first want the router to see, hey, actually there's this type amount in user currency. I first need to go to that user type. I need to reference the user by the ID. I need to go to the user type defined in the user subgraph, go to the currency field, and then select the ISO code, and then pass that all backwards up the chain to then select that data and pass it into that code argument, right? So how I can do this is with this new GraphQL context. There's the new context directive, but first I want to talk generally about the context itself. GraphQL context, a general term, is typically something used in the server implementation where it's a generic container, you can put data into it, and across the execution of a single request, you can reference different things you might put in there, right? It's commonly used for maybe headers, authentication codes, whatever it is. A lot of the server implementations have this. Router even has this, right, if you're doing coprocessors or scripts. But the key here is that this is something inside the GraphQL runtime. This isn't exposed to the users. This is just specifically to the server code that we're handling something on every single request. We need to share data between our functions, right? So that's exactly what we support now in these new federation directives. And the new directives we have are at context and at from context. This allows you to share data across your query plants. So how can we use these fields? So going back to our simple example, let's now just look at one subgraph, right? We're just looking at the transaction subgraph. We want to reference another field that we know exists on the user type, this currency code. We want to get that into the transaction subgraph. So first we need to declare what fields we want to use. And we do that by saying there's some type out there called the currency field on the user, and I don't own it, I can't resolve it, it's external, right? That's why we use the external directive, right? So it exists somewhere else. I don't even know what subgraph it exists on, I just know it does exist, right? And also since it is a nested type and not just a field, we have to also declare the type and then mark the field that we also want as external, right? Once we do that, then we get to the new features. We can say, I want to set some context up at the user type, right? I'll get into where this can exist in a second, but that user type declares some context. I call that whatever I want, Shane's context, foobar, doesn't matter, just give it some unique name, right? And that now declares a place I can go reference data later. And then how I reference that data is with the new from context directive. So from context now allows us to specify a field that we want to pass in to this argument. You'll see the from context directive is annotated on the argument itself, right? So we're selecting one field to pass into this argument. So we specify the $ name of the context, that unique name, and then we do our field selection. Again, let's map to one single field. If you have multiple arguments that you need to resolve there, then you just do multiple from context. You don't need to declare multiple context definitions. You can reuse that, but you do need multiple at from context. Context is if you need to define those. Okay, so the query.context, then what it does is when we annotate that argument with that new directive, this actually strips that argument from the supergraph. So now from client's perspective, this is the query I get to write. I just get to say, I want the user, the transaction, and the amount in currency. There actually is no argument for me to pass in as a client consuming the supergraph. The router and the federation hides that from you. So now I don't have to worry about going and querying the user first and then getting all the data and then passing it in. The subgraph owners don't have to do this. This is now a declarative way that you can pass data across your subgraph boundaries and start getting into more advanced of those query plans. All right. Again, you don't have to worry about where this moves. If you move that currency code to a new subgraph, it doesn't have to change, right? Because we're not defining anything here. And if you want to see a little bit more about what happens on that query plan, again, open up the plain text view. You'll see here it actually stores it in a contextual argument in the router query plan. But I will call out, this isn't for free. You might get some data, you might get an extra query added to your subgraph or your query plan if you need to go select stuff you weren't doing before. But again, we needed that anyway, so really we're actually saving and caching all the data in a single query plan. So to use this stuff, we need to be using Federation 2.8. It does need to be scoped to subgraph boundaries, so I can only use an at context within one subgraph. I can't declare at context and then reference that in another subgraph file or another subgraph schema. And it also needs to be on the parent path, right? So it must be some way for me to get from that argument. If I go up my chain of the parent definitions and type definitions, I need to somehow hit that context that way. I can't go up and down, it needs to be on the parent path, right? But this allows for, again, that declarative build time validation of our schema. And again, if you want to learn more about how this is impacting your operations, check those query plans, start inspecting the number of fetches you're doing. That'll help you kind of see what's happening under the hood. Do have to call out, as we mentioned in the keynote, this isn't supported right now in the new native query planner, but that should hopefully change soon. So if you're watching the recording later, hopefully you can try it out now in the new native query planner. All right, so we talked about query plans, talked about the context directive. Everything we talked about today is existing in Federation, but what I want to talk about next is a glimpse to what entities will become in the future. You've heard in the keynote that we talked about this new spec that we're working with the GraphQL Foundation to create. And so I want to kind of highlight the work that Apollo has done, as well as many members of that working group has done, of which I am part of. And I've joined a lot of these working group meetings to help define the future of the Federation spec. First, though, if you want to learn more, since I only have about 8 minutes left to actually really talk about all of this, there was a whole panel done at the GraphQL Conf just in September. There was multiple talks, so I recommend go checking out the GraphQL Conf videos, which is put on by the GraphQL Foundation. We specifically had a panel with some of the working group members from the Guild, Chili Cream, Apollo, and so we got to answer a little more in-depth questions about what this all means, like what's the spec, what was the release time we're thinking about here, all that and more is kind of answered in there, but I'd also be happy to talk about those later at the happy hour if you have questions for me too. Our current Git repo is the GraphQL Composite Schemas Working Group. If you're not familiar with the Foundation model, they have the core spec for GraphQL, but there's all these different subcommittees too. So we are in the subcommittee for creating a new GraphQL Federation spec. The working group itself is called the Composite Schemas Working Group, and hopefully the output of this will be some Composite Schemas spec, tentatively called the GraphQL Federation, because that's what a lot of us refer to, but the name's still not yet decided. But our goal is to create a standard industry standard that would be a collaboration from many different GraphQL vendors that will hopefully create a consistent and available specification for you, the API owners, to use, right? We want something that is adopted across the entire vendor ecosystem of GraphQL. If you want to learn more, you can check out the GraphQL Composite Schemas spec repo, which is in the GraphQL org. A lot of the work is happening in pull requests and documents, so it's still early phases, but if you want to read up more, you can do that there on the GitHub repo. But what is the goal of this spec, right? The goal is to, again, create something vendor agnostic. It's not something that is going to be code specific for just Apollo or just Chili Cream or just the Guild or any other vendor that's there, right? We want something that's a specification that everyone can adhere to, all the vendors can adhere to when they implement their federation gateways or libraries or whatever we build. This is, again, coming out of a working group. The working group is called the Composite Schemas. If you want to join the working group, you can, right? And you can impact the decisions we're making there. But the spec that we are creating right now is going to be an iteration on top of what we've learned from the industry best practices, which comes from both Apollo Federation and Fusion, right? These two different federated GraphQL implementations have seen use in production, and so we want to take those learnings and bring out a core idea of what things can be used across many different implementations. That doesn't mean everything in Apollo Federation will make it into this new composite schema spec. It's going to be a subset of the things that are fundamental to running a federated GraphQL ecosystem. Again, we're defining how and where things can be composed together, what the directives are, but we're still leaving it up for implementation details of vendors to allow for creativity, to allow for differences in ways that you might do query planning or composition or whatever that means that might optimize for your customers' use cases, right? We don't define the implementation details, just the spec and how the common output that we expect from those processes. Again, the working group is still, and the spec is still a work in progress. We're in phase 0 of 3, so we got a long way to go before we actually get to a final accepted spec into the foundation. But that being said, a lot of the members contributing today are from Chiller Cream, the Guild, Apollo. We're the most active participants right now. If you'd like to see your name up there, please join the working group, right? This is how we create a true community spec standard, is to get everyone from the community to join in on this effort. So go to the repo, check out the working group, and see how you can attend and contribute. But now that we all know what's happening, let's talk about what things we've sort of talked about in the working group. 3 things I want to cover is the new @lookup directive, GraphQL batching, as well as standardized testing. All right, so the @lookup is going to hopefully help us solve this magical query._entities field, right? I said, as I sort of explained how the router works today, is that it needs this field to exist, because this is the way that it knows I can go ask for an entity. I give you the keys, you tell me, I tell you what fields I want, and you go resolve all that stuff, right? Because we built it with the _entities, accepts the array and all the different types, that allows us to do the batching mechanisms that we require. But that also means I can't add, to support federation, I need to add that resolver in this special field, and I can't add it to some third-party code or third-party API if they don't implement that specification. So the new @lookup directive is going to allow you a way to annotate the resolvers that you might already have in your schema as entity resolvers, right? So we can say, right on the root query, hey, I have a way already to resolve a product. I have multiple ways, because maybe I have multiple keys for a product. A key for a product could be its ID, its name, maybe both of them. So if I already have these root level resolvers already built, I can just annotate those as, hey, router, if you need to go look up an entity, here it is. Use this one right here. And I don't need to go build a special function to go do that. This also works really well with the relay node pattern, right? So if you're using the relay spec and you're using global IDs for nodes and interfaces, this will easily just add @lookup to the @node field, right? And right there, you got entity resolvers for your relay spec. The other part of this is it's just a directive. So if this schema exists today without the lookup directive, maybe this is a third-party GraphQL API that has this schema, I can add a transformation layer or just a small little extension layer to add those directives for that third party, and then I can publish that to a federated schema. And then I can start federating this schema, this third-party API, even though they don't even have these directives annotated, right? This can be an additional metadata layer on top of the schema that you already have. Yes. Next one I want to talk about is batching. So let's say we add @lookup, right? We can look up a single entity by its ID, but the power of federation is we obviously want to solve the n+1 problem, right? We want to query for a bunch of entities all into one. Now we could maybe add @lookup and get like a list of things, but then like you pass like a list of arguments, and we've discussed this in the working group. It gets a little more complicated. So what we're proposing is actually a couple of different ways you can execute any GraphQL operation back to another working group, which is the GraphQL over HTTP working group. They are the ones specifying a bunch of ways that GraphQL doesn't necessarily work over HTTP in the standard spec. We are adding to that definition with a separate working group. And so we're proposing a couple ways that we could do batching with that working group. The first one at the top here is what we call request batching. So request batching allows us to specify multiple GraphQL operations in a single HTTP payload, right? So we can say, here's an array of GraphQL operations. Please go execute every single one of them. In this case, the demo I have, we're selecting different operations that could be all the same, that could all be different, but it just allows you to specify an array. This is supported today by Router and Apollo Server, so a lot of Apollo clients even use this method, but it's not standardized per se yet, so that's why we're posing it back to that group. The other one in the middle here is what we're calling variable batching. So today, the variables in GraphQL usually are just specified as a JSON object, but in theory, if you have a single query that accepts some variables, like go select the user and its name, and I have an user ID, I could go execute this every single time for every entity by passing in all the different IDs as variables, right? So I can use that array of variables to go select multiple entities. But even more powerful, you can actually combine those things together too, right? You can have an array of requests, which has an array of variables. And so this would allow us in a standards way to implement many different ways that we could fetch and resolve entities from your different subgraphs if they all supported this new proposal, not yet adopted, but a proposal into the HB working group. And then lastly, I want to talk about the work the group is doing to hopefully have a compatibility test suite. We know if and when there is a new spec released, we want to make sure that it can be well adopted, and the best way to make sure the adoption moves quickly is to give a standardized suite to validate your implementation, right? This would help Apollo, this would help all the other vendors, or just anyone else who wants to go build your own federation implementation. There should be a standard audit and test suite that is owned by the working group that anyone can use, and as we add new features or find bugs, is also updated with that tests. We don't have an official one today, but the working group has talked with the guild on maybe adopting or forking or whatever we do, just using as a base starting point their GraphQL Federation Gateway Audit repo. This already exists today. It already helps validate some stuff. They don't run the new router query planner on that audit yet, and so that still needs to be updated. But this could be a great place, again, for the working group committee to have a standard validation repo that everyone can use. And I don't have time to talk about it today, but we're also talking about few other directives, like the @require directive, which is going to allow us to do other argument mapping, very kind of similar to actually it's not similar, but it allows us to add other arguments and remap them to the output of the types. @is, again, allows us to map arguments back to different fields. We're thinking about adding a new @internal directive, which allows fields that only be accessible at the router. If you want to learn more, again, I recommend you check out the Composite Schemas Working Group repo. All right, so final exam, all right? Hopefully we all took something away. I just want to highlight that if you want to learn more about query plans and what is happening with your fields, your executions, go do a deep dive on the router query planner. Open up that plain text view. It tells you exactly what's going to happen on the router, right? And it allows you to go really understand, like, when it says fetch, like, what is it fetching? How is it fetching? Is that the reason that that field is slow? Am I fetching too much? Did I overload my query plans? So go start learning how the query plan executes and runs. They'll teach you a lot about your federated GraphQL. You should only use keys as true IDs. Don't use them as containers to pass data around, even though they do have that option. And then use the @context when you need to pull data across those type boundaries. So if you need to, again, share data up and down your parent types, use the new @context directives rather than keys, or even maybe @requires, because it does limit you to specific types. And then the future of Apollo Federation is open, right? We want everyone here to contribute to Apollo Federation and hopefully the new GraphQL Federation spec that will be driven by the community. So that's it for me today. If you want to learn more or chat with me about all the different stuff I talked about, I'll be at the party tonight, or you can find me here after my talk is done, or you can reach me at most socials. I'm at Shane Myrick or shanemyrick.com. Thank you.